Hey folks, we are Team Wave Wizard and our problem statement ID is 1694 under the theme Smart Automation. Our problem statement title is Real-Time Ganga River Water Quality Forecasting using AI-enabled DSS, satellite data, IoT and dynamic models. Ganga, our lifeline is facing threats. Let's unite to protect her purity and ensure her flow for generations to come. So why did we choose this problem statement? It is a central government-based problem statement. If our government is emphasizing on this problem statement, so it's our responsibility to work on it. So Ganga Navjeevan, a project in which we are ensuring to retain Ganga original water quality as it is. So Ganga Navjeevan ensures to create an AI-based decision support system for monitoring and forecasting Ganga River water quality integrated with satellite IoT simulation to enable long-term river health assurance. In this project, we will be covering several parameters which includes TDS, total dissolved solvent, pH, whether the water is basic or acidic, oxygen level, dissolved oxygen level, temperature, and several water discharges. Prediction of water quality, precipitation and temperature. Prediction will be also covered in this app. In dashboard, we will also include a map with several parameters which are responsible for water quality management. Parameters as well as 10 days time series and 3 days forecast for Ganga River. Alert will be timely given in case of any spike in parameters like pollution, overflow, pathogen count, and nitrate spike exceeding thresholds. Status of provision of information in relation to tributaries and canal water quality management. Our data will not only be limited for government utilities, but we will also sharing our data with researchers, scientists, people living near riverbed. Our problem resolution. There is a possibility of utilizing the prediction data in construction of an operative AI-enabled decision support system. Our system will send timely alerts in case of any spike in parameters, which will be generated from the data that has been analyzed to demonstrate water quality estimation. Coming to the unique value proposition, which are basically UVP of our problem. Based on community feedback, our DSS will be trained. Community feedback for cross-validating and further updating. Decision support system can be trained by community feedback also. Proactive approach toward water quality management. Our system will only be limited with these parameters, but we will be continuously adapt to new parameters, ensuring its accuracy and relevance in dynamic environment. Now my other teammate will explain the technical approach.
Now moving on to technical approach, this would be our tech stack. In the front end, we'll use HTML, CSS, JavaScript, and React Native. For the back end, we'll use Python and its libraries, TensorFlow, OpenCV. For databases, we'll use OpenTSDB and InfluxDB. And AWS would be used as cloud platforms. IoT data would be tested using COAP and MQTT. For hydrodynamic models, we'll use OpenMPI and PyHydro. Now moving on towards the working of our app, the user would be given options for which the data he requires. There would be a main ML channel which would fetch the data from the required APIs. These APIs would move the data for further processing to their personal AI models, processing and forecasting. This would now be forwarded to the main ML channel. Now also the forecasting would be done through the main ML channel, and thus the user required data would be displayed. Also on timely basis, the processed data and the integrated data would be checked for proper alerts. Databases would store the raw data and the processed data as well. The forecasting would help in developing an AI-based DSS. This AI-enabled DSS would give insights and used for giving alerts, and thus how a proactive approaching model would be created. Data collection would be from satellite data, IoT sensors, IMD data, and population data. And we would have an AI-enabled DSS, giving insights and actionable alerts. For data processing, we'll use APIs which would help in integrating data. ML would give some uniqueness and identify patterns and trends. What would the future water quality conditions be? Now for the feasibilities, challenges and the strategies would be explained by my teammate.
Impact and benefits. Let's start with potential impact. First is improved water quality. The system predicts potential pollution issues to ensure cleaner water, protect biodiversity, and safeguard public safety. It continuously monitors water quality parameters like pH, dissolved oxygen, and pollutant level in real time, providing instant update. Second is reduced pollution. The system helps reduce pollution by forecasting events and identifying sources, ensuring cleaner water and healthier ecosystem. It can track industrial discharges to ensure alignment with environmental standards and guide farmers in adopting sustainable practices that minimize the agricultural runoff and protect water quality. Third is impact on biodiversity. The system helps maintain clean water, which is vital for ecosystem health, species conservation, and a sustainable future. By preserving habitats and protecting biodiversity, it supports diverse aquatic life and the conservation of endangered species. Now, benefits of the solution. First is public health improvement. The system can improve public health by reducing waterborne diseases like cholera, typhoid, etc. through cleaner water and early detection of contamination. It ensures that the water supplied to household is safe for consumption by preventing health risk and enhancing the overall quality of life for communities. Second is proactive water quality management. The system enables proactive water quality management by predicting and addressing pollution issues before they occur. It helps assess potential risk, prioritize solutions, support decision making for policymakers, and adapt strategies based on changing conditions. Third is cost effective solution. The system provides cost effective solution by optimizing water quality management, which help reduce operational cost and improve efficiency. By targeting specific problem areas and minimize unnecessary intervention, it ensures resources are used effectively, saving money while maintaining high water quality standards. Now, feasibility and viability, starting with scalability. As the system grows and covers more area, it needs to be able to handle the increased workload without slowing down. This might require more powerful computers or better software design. Second is user interactivity or user friendliness. The system should be easy for people to use, even if they don't know how much about technology. This means making the interface clear and simple. Third is merging with existing system, or we can call it integration. The system needs to work well with other systems already in place, like those used by government agencies or water utilities. Now, challenges and strategies to overcome those challenges. First challenge is data inaccuracy. Sometimes the data collected by sensors might not be accurate. So, validation and feedback. To ensure data accuracy, the system can compare reading from different sensors or ask users for feedback. The second challenge is false warning and alert. The system might mistakenly predict a problem when there isn't one. So, community input is the strategy. People living near the river can help verify if a warning is real or not. Third challenge is computational resources. The system needs a lot of computing power to process all the data and make predictions. So, data efficiency. The system should only process and display the data that's truly necessary. The fourth challenge is data integration. Combining data from different sources can really be tricky. So, by doing data fusion, like using multiple sensors, checking data, combining information, and using models can help make data more reliable.
Now at last, we have given here researches and references. We have given the data sources such as daily precipitation and temperature obtained from Mausam Vibhag, satellite data and land use from BOD, population from Census of India, and river water quality. Research papers are given here with the links and their writers. So this is our proposed solution for the problem statement, and thank you all for attentively listening. Now sharing with you the prototype of our website. This wouldn't be an actual website but an idea how our website will work. For example, we have given here homepage, contacts, galleries and projects, a search bar and a sign up menu in which user could sign up. Also we would add a map here. Through this map the user could scroll down and see for the cities and the parameters. But the map is still under development. For now we have given a more such cities here. Let's say I select Haridwar. Now we move on to a page where the details about Haridwar are given. Now here a temperature is given. Now the city description is given, where it lies and all that. Along with it, the parameters are given here. Suppose I select the parameter pH. The details about pH and the ranges etc. are given. The pH of last 7 days is also given here. Based on that, a graph is given. Also, the forecasting of next 3 days is given. Likewise, it's for rainfall, temperature, oxygen demand and TDS, and also we could add further parameters here.
Thank you.